Name the quantity which is measured in kilowatt hour. I've written energy. And second EV, that also I've written energy. But I've written energy in electrons.
For kilowatt hour, like even work is there, right? Or
Kilowatt hour work. Has anybody written work?
Work and energy is the same, right?
Yeah, energy work value is the same, so I think it works for both.
Okay. So then state the energy conversion in the following. For electroplating, I've written electrical to chemical.
one
Then
second. Hi Swara, we just started discussion. Like we're on the question 1B.
Okay. So the first two are both energy, right? For kilowatt hour and electron volt.
yeah, for EV you have to write energy in electrons or atoms, anything.
For EV,
Then
can we also write electrical energy because it's
no, I don't
usually
think so. Electrical energy will be right
also.
because it.
But we can't measure any other amount, any other energy in electron volt.
But electrical energy, then you're studying electricity. Then in that we have na joules.
Yeah.
But like one quantity can have more than one unit now.
Yeah, I don't know, but I think it's wrong. But better answer is in atoms only, no? Because that is given in textbook.
Okay.
Then endothermic chemical. Yeah.
Sorry, but can you please repeat question? One, the first one.
First one is energy or work also. Then endothermic chemical reaction. I've written heat to chemical. I'm not sure if that is right.
Isn't heat evolved, so it will be chemical to heat, right?
It's an endothermic reaction. Heat is lost.
Heat is lost. Exothermic heat is evolved.
But before like getting lost, like it is first formed now in the reaction.
Yeah.
Even I wrote heat to chemical because the heat energy absorbed, I think the energy which is absorbed is used for the reaction.
Even I've written heat to chemical.
Yeah, same.
I wrote chemical to heat because like in the reaction first it is like evolved like and then it is absorbed like. For how, like when is the heat formed? Like is it isn't there from first now in the reaction.
But why will it be
Usually when we see in an endothermic or exothermic reaction, heat absorbed or evolved is a product and not a reactant. So won't it be after? And after the chemical reaction takes place, heat is absorbed or evolved.
But how is heat being absorbed? The product doesn't, like the heat will be used for the reaction only, no? If it's being absorbed.
Yeah, heat is used for the reaction. So heat is used for the chemical reaction.
Like for any reaction, like first you have to supply it from outside, and then after like the first stage, only then like we stop the heating, and then like example ammonia is also like.
Differentiate between free and damped vibration. I've written free vibration are the vibrations of a body without the influence of any external periodic force, whereas damped vibrations of a body are the vibrations of a body under the presence of external damping force. And then second point, vibrations are of constant amplitude and then vibrations are of decreasing amplitude. Then for D, I've written the answer 2:1. And E, state one advantage is we can apply effort in a convenient downward direction, and disadvantage is that its mechanical advantage is less than that of a single movable.
We can also write that force multiplier.
Yeah, you can write that.
Okay.
First one, I'm not sure of the answer, but first I wrote false and the second one I wrote true. Is that correct?
Yes, that's right. Even I wrote that.
Yeah, when I wrote the same.
Second one different. Can someone tell me why the second one's true? Because I think resistivity is specific resistance, which again depends on the area of cross section, so it's not going to be.
Resistivity is a property of the material. It doesn't depend on length or area.
It is same for same material.
It's the same way of copper now, so like it will be same.
Okay, I think I'll continue. Differentiate between chemical and nuclear changes. I wrote chemical changes leads to a change in the number of orbital electrons, while nuclear change causes change in the number of nucleons. And the second point I wrote, chemical energy requires a lower amount of, chemical change requires a lower amount of energy, and nuclear change requires a much higher amount of energy.
Can you
Do we
repeat
have
the
to-
first one?
Lower energy and higher amount of energy. I don't know if that's valid, but
Do we have to mention the amount of energy also?
Like I guess
Probably.
like this like second point should be that new element is formed and new element isn't formed. Because in
yeah, maybe.
I have another point. Can we write that chemical energy depends on the activity of electrons and nuclear is for nucleons in the nucleus?
No, but I think
because-
that's the same as
That's
the
the
first
same as
point.
the first point.
I have another point. Chemical change is affected by ionization, reduction, oxidation, and nuclear change is not affected by ionization, reduction. That's right.
But isn't oxidation a chemical change, like on its own?
Yeah, but
Yeah.
nuclear change is not affected, right, by that.
Yeah,
Yeah, but in that
about,
electrons are only changed, na? So that is relating to electrons only again.
What about giving examples like for chemical changes, it's
I
chemical
don't think they-
reactions due to
I don't think
formation of
examples count
bonds?
as a force.
Yeah, I don't think they count
Unless there are-
examples.
For the
as a
second
point.
point, can we say that the chemical change it requires energy of only a few electron volts, and then on that side, like mega electron volts or whatever unit is given?
I
Or
think
just-
I think they have some value also. I'm not sure, but I think
I-
if there is a value, then I think
I guess that the amount of energy depends on the reactants. So like even in a chemical, if there's like a inert reaction, it will require a large amount of energy. So
But I think still, even if it is an inert reaction, nuclear will be much more than that.
yeah,
I don't know. That's
Yeah.
I think.
no idea.
should we confirm? Like, can we check the textbook?
Yeah.
We can check the textbook, of course.
Huh.
For that endothermic, I confirmed it again also. From Google also I confirmed it. It is heat to chemical only.
Okay. But like the heat has to be formed now. That's the only doubt.
But I think the heat energy which is formed is used for the chemical reaction. That's why it is heat.
Yeah, that's the definition of endothermic. But like before being used up, it has to be formed.
It is formed only, but then it is used now for the reaction.
Can it be chemical to heat to chemical again?
Yeah, I think that's what takes place. But we are supposed to write heat to chemical to heat. I'm sorry, heat to chemical.
So the last stage reaction, whatever.
It's written here, a nuclear change requires much higher energy of the order of few mega electron volt, which is nearly 10 raised to 6 times as compared to the energy required for a chemical change, which is of the order of a few electron volt only. That's the only thing they mentioned, and the first one which Hitanshi said.
So we can write that.
Which chapter is this answer in? It's not in radioactivity for sure. Is it in?
It's in radioactivity ka blue box on page 285.
Hitanshi left, I guess. So like someone can continue now. Like Mala using.
From which, like the question, next question, or
Question 2. We can do 3 now and then she'll come back.
yeah.
Yeah, so do question 3.
So I'll discuss three. Wait. Figure given below shows distance displacement graph of two waves A and B. Compare the amplitude. The wavelength of the two waves. Compare the amplitude. I got 2:1, and wavelength of the two waves 1:2. Then B, define specific heat capacity of a body. I don't think mine is correct.
You can try. You can say that.
Chao, I'll try then. Specific heat capacity of a body is the amount of energy required for a unit mass of a substance to raise the temperature by 1 degree Celsius.
It's not wrong, it's right. But just frame it like in a different way, probably.
Acha, okay.
That beach का part वो added extra में like 1 unit mass नहीं उड़ा added extra like specific heat capacity of a body is the amount of heat energy required to raise a unit length of that material by 1 degree, I guess.
Length.
No, I guess no.
Mass only.
Unit mass
Sorry.
State its relation with the heat capacity of the body. Heat capacity is the product of the specific heat capacity, rise in temperature and mass of the substance. Then I've written the C dash equal to MC delta T.
C dash is equal to MC, not delta T. Q is equal
delta
to
T is
MC
for
dash.
Q.
Okay.
Can we just say heat capacity is directly proportional to the specific?
I think you can say that, but then you need to give the formula also because that's what they will be expecting.
C1. What is the name given to the elements with the same mass number and a different atomic number? Isobars. Second, under which condition does the nucleus of an atom tend to be radioactive? Yeah, I didn't get this.
I think it's when the number of neutrons in the nucleus are much more than the number of protons.
Yeah.
Is there any specific number for how much more they need to be, or like do we need to mention by some margin, or can we just write
No.
much?
Just
No,
I think you can just
there's
write
no
much
number,
more.
but they have mentioned that elements above atomic number 80 are usually radioactive in nature.
Okay.
So I've written when they are reactive when the atomic number is greater than 82 or the number of neutrons is greater than protons. So is that right?
I think so.
Like radioactive can also be like when they are less than 80, right? Because they form radioisotopes like when they are less than.
Yeah, they've said that they are usually radioactive above 82, but that doesn't mean
Okay.
that they're below 82 or not.
Okay.
I think that point might be a little contradicting, but you can write at the end that usually elements above 82.
I'll write it later after writing that neutrons should be greater than protons.
Yeah.
We can give only 1.2, right? Because it's a 1 mark question.
Yeah.
Yeah.
D. Arrange alpha, beta, and gamma radiations in ascending order with respect to their penetrating power, alpha, beta, gamma, and ionizing power, gamma, beta, alpha. Yeah. Then E. One second. Yeah. The diagram shows a balance being used to find the weight of a baby. The weight of the basket can be ignored. At equilibrium, the pivot is nearer to the weight W than to the baby. What is the weight of the baby? Is it less than or more than equal to W? State the principle applied. The baby's weight is less than W. The principle applied is the principle of moments.
And there was one question: what is the weight of the baby? I didn't understand that.
Exactly. How do we even
No, I
find
don't think
that?
you have to calculate. You just have to say whether it's less than more than.
If they,
But then that they have already asked in the second part.
Do we
But
have
no,
to
that-
assume it? Do we have to assume the distance between the baby and the pivot to be D1 and weight and pivot to be
No,
D2? And
we
No,
can't
I don't
do
think
that.
we
find
can
it like that?
They
You
meant
can't.
to keep the whole question like the less than, more than, or equal to W.
Yeah, because one mark is for saying whether it's less than, more than, or whatever, and then second mark is for principle. So I'm pretty sure we don't have to calculate. Also, I'm sorry, but I think I got disconnected. Did you all complete question 2?
No, we
We
left.
No, you are supposed to complete it.
Okay, should I continue?
Yeah, you can resume. Yeah.
We did we did B. So now see, write the position of the center of gravity of the following objects. First is a solid cone. I've written at height h upon 4 from the base at the axis. And second is triangular lamina, point of intersection of the medians. Question D, an electrical kettle is rated 3 kilowatt, 250 volt. Give a reason whether this kettle can be used in a circuit which contains a fuse of current rating 13 ampere. So 3 kilowatt is 3000 watt, and the safe current limit would be 3000 upon 250, which is 12 ampere. So I've written that it can be used in a circuit with a fuse of current rating 13 ampere. And question E, first one, when does a ray of light falling on a lens pass through it undeviated? When it passes through the optical center. And second one, which lens can produce a real and inverted image of an object? Convex lens.
So I've written it passes undeviated when it passes to the center of curvature. Is that right?
How center of curvature?
Isn't center of curvature and that optical center same?
No,
Or is it
no.
different?
Center of curvature is
2F, 2F2 and
Okay,
2F1.
Okay.
Very
But I have a doubt. For this question, why can't we write that the light ray is incident normal to the lens, or when the refractive index of the first medium is the same as the second medium? Like, how do we differentiate between these two questions accordingly?
I guess for the refractive index one, like it is only applicable for a thin lens because it is given in the textbook when like if it is not a thin lens and the light is parallel when like as compared to the first ray.
Yeah, they actually they haven't. I mean, I thought it was a pretty confusing question. What do they exactly expect? Do they want us to answer according to convex and concave lens or any normal lens?
I think they will want us to answer in terms of convex, concave only.
Convex and concave. Yeah.
So then it will be optical.
Yeah.
If they say a glass block, then we can write incident normally. But if
Yeah,
they
even
say
I was thinking. Yeah.
lens, then I don't think so we can write that.
If it's incident normally on the lens ka mirror, isn't it just
Yeah, I mean, I don't know how it. I don't know.
isn't it parallel? So I will go from the I don't know.
Focus. Yeah.
Not incident normally, incident at an angle of 0 degree.
But
It will be. How will it go?
Array,
How
see,
how
that
how
example
will we
first.
decide the how will we decide the normal of the lens?
exactly. So I don't think it's even applicable.
Okay.
No, I'm saying for glass block. I'm not saying for
Yeah,
lens.
glass block.
Glass block, yeah.
Because then that way the incident ray will have to be on the principal axis or to
Yeah.
pass and
Yeah, and then it won't even.
oh god.
Question 4 then. Mala, Mishti.
Okay. So question 4A first. What is a superconductor? A superconductor is a substance of zero resistance at a very low temperature. And if a wire is stretched to double its length, what will be the change in its resistance? The resistance will also double because resistance is directly proportional to length of the wire.
I've written resistance will become 4 times.
Same.
Then I've written 4 times.
Because if you double it, the area becomes half.
Area
and
becomes half.
Inversely
Yeah.
proportional.
Sure. Yeah. B. To which wire of a cable in a power circuit should the metal case of a geyser be connected? The earth wire. What is the color code of the wire to which the fuse is connected? So it's the live wire, hence it's brown.
Do we have to write the old one or the new one? Convention.
I think new.
One.
If you write both, is that okay?
Yeah, then
Yeah.
you're just being safe, so that's okay.
But that will confuse the examiner, I guess. No?
Yeah.
I think either will be okay, but both I don't know because Miss said that don't give us options because we will choose the. I don't know.
I don't know.
We-
But
we
if you
can
mention
write-
that the according to old system, it's this. and
Yeah,
according
new
to this
system. I don't think
that's okay.
I think instead I should write old convention then that instead of writing red and
Yeah, exactly.
brown both.
What was the answer for the first one? It's Earth violet.
Yeah.
Yeah.
Should I go on?
Yeah.
The earth pin is thicker and longer than the other two wires explained. So the earth pin is made long so that the earth connection is made first in the other two connection. This ensures safety of the user, as if the appliance is defective, the fuse will blow out. The earth pin is made thicker so that even by mistake it can't be inserted into the hole for live or neutral connection of the socket. D. A girl claps and hears the echo after reflection from a cliff which is 960 meters away. If the velocity of the sound is 320 meters per second, calculate the time taken for hearing the echo. I got 6 seconds.
Same.
The fifth one, in the circuit shown alongside, calculate the value of A if the equivalent resistance between A and B is 4. I got 8 ohms.
I got 3 ohms.
I got 3.
Even I
ohms.
got
Three.
3.
3.
Like first, like 1/4 is equal to like what did you do? Like 1/8 plus 1/5
So,
plus A.
8 ohm and 5 plus A are in parallel, na? So you do 1 upon 8 plus 1 upon 5 plus A. 1 upon RP is equal to 1 upon 8 plus 1 upon 5 plus A. Then you have to take
And
LCM and
cross
solve it. You get the
multiply.
value of A.
Calculation error.
12 is equal to 4A.
Yeah.
The first answer for the weight, I got 105 GF.
Yes.
Then B, complete the following sentences. The SI unit of moment of force is Nm or Newton meter, like whatever you want. And in equilibrium, algebraic sum of the moments of all forces about the point of rotation is 0. In a beam balance, when the beam is balanced in a horizontal position, I wrote it is in static equilibrium.
For
Yeah,
the
even
first
I-
one, for the first one, what was it?
Newton meter.
No, like A part.
Oh, 105 gram force.
I got 420 gram. Like
I got 105, but why did you write GF? Like, why won't it be just GF?
Yeah, I wrote 105.
Yeah, 105 grams. I just solved it.
I think.
I mean, I make it G. I just thought like GF and G, like, and those sums usually use GF now.
Even I wrote G.
But I think if in the question they
Yeah.
mentioned, I don't know.
in the question, like
Confusing.
whichever unit they mentioned, the answer should be
Yeah.
Yeah.
But in the principle, it says weight into distance, but G is a unit of mass. So to convert it to weight, it's GF, right? Because it's numerically equal. And
But
if
then where did you
they
get
have
the
asked
F
the
from?
weight, they have asked the weight of the rule.
Yeah, probably. Because it says mass of 20 grams.
So
Yeah.
weight will be 20 gram force.
Okay.
okay.
Then for
And when
this,
do we write? Sorry, when do we write 20 GF centimeter? When do we write GF centimeter?
when you multiply the force by the
That is for moment of force, right?
Yeah, that's a moment of
Okay, thank you.
Then for C, the first question was diagram. I didn't draw it. Then the second was mechanical advantage. I got 3.75.
Even I got.
And then for the third one, like I just wrote 10 meter, but like what working to show.
Working will be VR is equal to DE upon DL. So 5 is equal to DE upon 2. DL is equal to 10.
Acha, cool. But 10 meter I got.
Yeah, 10.
Give a list of at least 5 radiations in the order of their increasing wavelength, which make up the complete electromagnetic spectrum. Wavelength increases from gamma to micro or radio, right? I'm not wrong.
Yeah.
Two radio.
But you have to name 5. I think.
Yeah, so then it's gamma, X-rays, ultraviolet, visible rays, and infrared. And which of the radiation mentioned by you in part 1 is the highest biological damage? Gamma. An electromagnetic wave has a frequency of 500 megahertz and wavelength of 60 centimeter. Calculate the velocity of the wave. So the 60 we have to convert it to meters first, which is 0.6 meters. And megahertz to hertz, which is 500 into 10 raised to minus 6, right?
Plus 6.
It will not be minus, just 6 hertz.
But aren't we converting megahertz to hertz?
So
we're
mega
coming
will
down.
be 10 raised to 6, or 10 raised to minus 6 is micro.
Like mega is bigger, so like the normal hertz will be like way like larger to compare. Kg and gram like.
Yeah, minus 6 is micro actually.
One megahertz is 10 raised to 6 hertz. Yeah, okay, fine. Yeah, sorry. I always make mistakes in this. So V is that's lambda. And I'm sorry about the cooker. Please 300 into 10 raised to 6 meter per second.
Yeah, so that will be 3 into 10 raised to 8 meter per second.
8, yeah.
How did I get 300? I got 30.
Doesn't matter now. What did you get into 10 ka power?
30 into 10 raised to 6 ms minus 1.
Huh? How? 0.6 into 500 into 10 raised to 6. And it will be 300 into 10 raised to 6, which will be 3 into 10 raised to 8.
How do you make it 0.5?
0.5?
0.6.
Just can you repeat your calculation?
I think because you didn't convert centimeter to meter.
60 centimeters equal to 60 upon 100.
0.6 meter.
Yeah, I did that.
Yeah, so multiply 0.6.
You probably
into
made a mistake
500.
in the number of zeros.
Yeah, one. Yeah, got it.
Then in the B part, they have written which is the highest biological damage. But if we haven't mentioned gamma rays, then how will we write gamma rays? Because it is mentioned by you in part.
The maximum frequency one.
Okay. Thanks.
Yeah, the first one is 65 angle of incidence at PQ, angle of refraction at the same interface, that is 25 minus 30, 35. Is 35 right?
Yeah. 65
I got 35.
A critical angle for glass air interface 42 degrees.
No, it's 55, I think so. I got
Yeah,
55.
They're asking for QC over here, so it's different.
55, no?
Yeah, because like alternate angles say we get 35 and then like iska corresponding.
Alternate angles.
No, first we get 65, like 35 for BCQ and then like uska complementary we take.
Complementary, no, not alternate.
First alternate and then complementary angle, na.
But where have you parallel lines? Where do you have parallel lines?
The normal for the first ray
Okay.
and QC. How did you solve them?
I solved sum of angles in a quadrilateral 360.
That is a long method.
How wrong, but then it will be.
I told long, not wrong.
It doesn't matter, maths. It's a physics paper, anyways.
Also, I have a question for the refraction one. I got 30 because from the normal, if you count 35 on this side, then the refraction would be 65 minus 35, right?
For the second one you're talking about, right?
Yeah.
So like it's 125 like pura, so we just subtract 90 from there.
Yeah, but then that won't be the... Oh.
Yeah.
I was saying deviation.
Deviation. So what are the third one?
Yeah, and the last part, they've already given the mass. What do they want? Calculate the amount of what.
They are given total mass.
Total mixture ka mass. No.
Yeah, you have to find the mass of hot water.
How do we do that? I didn't get this one.
So you have to assume the mass of hot water to be x, then the mass of cold water will be 50 minus x. Then they have given initial temperatures of both. Final temperature will be 45 degrees Celsius. Delta T for cold water will come to 25. Delta T for hot water will come to 45. Then C is 4200. And even if you don't take, then it doesn't matter. Because when you do Q is equal to MC delta T, then we will use principle of mixture. Heat lost by hot body is equal to heat gained by cold body. Then CC will get cancelled. Then if you solve it, you'll get the answer, which will be 17.86 is what I got.
Even I got the same answer.
17.857 now, so we can write
Yeah,
17.8.
you can try. Yeah.
We need to find a little two decimals or
I don't know. I'm not
Only
sure
two,
about
like-
this because in maths, so we do 17.857.
even I
Yeah,
did 3
you
and
can do
then
that.
approximated to 2.
Yeah, because there are more than 3. So much we can't. Yeah.
Okay, thank you.
Question 7th, Isha. No, Vedant. is there. You attempted Vedant.
Yeah, on. The specific heat capacity of a substance A is 0.7 joule per kg, joule per gram per Kelvin, whereas specific heat capacity of substance B is 4 joule per gram per Kelvin. Which of the two is a good conductor of heat? A is a good conductor of heat. State a reason for one. A is a good conductor of heat as due to its low specific heat capacity, it acquires a temperature, that is, it gets heated more than B in a certain amount of time. If substance A and B are liquids, then which one would be more useful in a car radiator? Substance B would be more useful in a car radiator. Then the
I didn't
second one,
understand the second reason. What reason did you give?
because substance B has high specific heat capacity, right? So it will absorb more heat without much change in its temperature.
Used
No,
as a
no, the
coolant.
second one.
Acha, oh.
Second one.
Uh,
State a reason for
A,
one.
A is a good conductor of heat as due to its low specific heat capacity, it acquires a temperature, that is, it gets more heated. It gets heated more than B in a certain amount of time.
Okay, because I wrote it absorbs heat readily and less amount of heat energy is required to raise its temperature.
Yeah,
So will
same.
it be that? Okay.
Yeah, correct.
What about the point where it absorbs less heat energy and therefore it allows more electricity to pass through? Like copper, for example, it has low specific heat capacity, so it itself does not absorb a large amount of heat, right? Huh?
Yeah, so copper is a good conductor of heat only.
Yeah, that's why. So we can write that point, right? That it itself does not absorb a large amount of heat and allows more to pass through.
I guess
Yeah, I
that depends
think
on
so.
the thickness, right? A thin and a thick. In the calorimeter, like the give reason of using a thin copper rod, like that is like because it doesn't absorb much and all the heat goes to the water. So.
Actually, it absorbs heat energy, but it gets to that point very fast, so it absorbs less heat energy.
Okay, continue.
So the second one is a diagram. And the third one, I got
The diagram,
uh,
like what was it? Like first.
the first, there's TIR and then along the surface.
I got first TIR, then again TIR, then along the top.
Same.
Like it should like go like in the same direction as key, like the first one.
Jayendra, can you just present the screen? Then it will be better. We will understand now.
I've drawn it.
Yeah, okay, show your diagram now on your camera.
Is it
I think yours is wrong.
like first?
The first part is correct. Second part, it will go along the surface.
It should be TIR again, right? Because
First it's TIR and then along the surface, right? Or
I got TIR, and then along the surface, and then it went upper. Because
Yeah, I got same as Tisha.
but even if you do one TIR and then you take it down and then it goes along the slope, if your thing is shorter, then even that's correct. I think.
But how? Even if it's shorter, the same thing will happen, no?
No, if you get a TIR here and then it directly refracts on this wala surface, like this wala straight surface.
Are you can't do that.
that
Why
is
not
in-
if your block का size is enough?
no, because of that, like they have given like at the O is the center of AB, like to make that like ensure that I guess. So that
See, should I show you my diagram?
yeah.
yeah, Ganesh.
A bit down. Okay.
Tisha, you got same kya?
Yeah, I do the same diagram.
But what if we refract the ray to the surface BD?
Like they have given like O is the center of the circular part AC.
Yeah, but it is refracting on O, not directly on BD.
No, I guess he's saying that after the after the
Okay, after the
reflection. Yeah. I don't know. That can be.
Should I continue or?
Yeah. See.
So for the third subpart, the answer of the first subpart, that is the total resistance IO, current in ammeter 1.2 ampere, current passing through the resistor C 0.72 amperes, and potential difference across the terminals 5.04 volts.
Same.
What did you say for the D part? Anand?
0.72 amperes.
Can you repeat the second part?
0.72 ampere.
That's the third, sorry. The fourth one is 5.04 volt.
5.04. But how? It is
I
BD
got
across the terminal.
0.96 volt.
Even I got 0.96.
But
But you can use the formula V equals IR. No?
So 1.2 into 0.8.
Yeah.
That's
So
the
that will be
total.
good.
That's
that is
EMF.
voltage drop you're like calculating.
No. It is only across the terminals of the battery. So it will be,
So it will be that only, no?
yeah, capital
Voltage
I into small r.
Like terminals across the
Voltage drop is the between the in the electrolyte, right?
Voltage drop is between the two terminals in the battery because between the two terminals, ये तो electrolyte होता है.
I think that they're asking us to do the terminal voltage. I don't know.
Yeah, when I did that.
What did you get for the third part?
It says the current passing across the terminals, so it's terminal voltage only.
What was the answer for the third part?
Or 0.72 amp.
How did you get it?
We got different now voltage, so we got different answer.
No, but
No,
0.72
part.
will be same.
What formula to use?
I used V equals IR. I substituted for the resistance 3, which is in series, the outside parallel one. We can use the formula V equals IR. So V here will be 5.04 and the I will be 1.2. So we have to find the V used by the third resistance. So we can use I into R, which is 1.2 into 3. And then we can subtract that voltage from the terminal voltage we got. And then
for the third part, like there's a formula at the end of the textbook, like when there are two parallel resistors. So for like for example, in the PD across C can be the total current into the resistance of D upon resistance of C plus D. Like so, the formula will be like 1.2 into 3 ohm upon 2 ohm plus 3 ohm. So that
What answer did you get? Then
0.72.
7-2 how?
I just said na 1.2 into 3 upon 5. So 3.6.
But why? 1.2 into 3 upon 5. Why did you do that?
The formula is there na, like when the two resistors in parallel, so the resistance in C is equal to the total current into resistance of the opposite resistor, like that is 3 upon resistance of C plus resistance of D. So in textbook page 131, I guess.
And can I just
or you can just find the voltage used by the third resistor and then subtract it from the terminal voltage.
No, 131, sorry. Uh, 194. 194.
Yeah, 194 what part?
The second part, which is there. Above the example, second part. If current I is divided into two resistors R1 and R2, then I is equal to I1 plus I2. The same diagram is there, which is there, na? Like similar one is there.
So IR1 upon R1 plus R2 now.
Yeah, IR, like for here it will be IR2 upon R1 plus R2, because like if we consider R1 as C.
Okay.
You got now, Pura.
For the fourth one, then will it be finally voltage drop or terminal voltage? Like,
I
It should
guess.
be terminal voltage. It's across the terminals, right? So
For voltage drop, they like they specify what is the voltage drop. For terminal voltage, they like always they give across the terminals. So in the question only it says that.
so when I search on the internet, even there they are showing 0.96.
you can recheck your answer now. If you what voltage you have got, you can add the voltage of the parallel and see if it's matching the current.
Can we ask Miss? I guess that'll be better.
Yeah.
So which one of us is gonna email me about that first wala and this wala?
That is to pakka heat to chemical only. I sourced on the net also.
I think it's better to confirm because on net, like on all those sites, anyone can answer.
I'll mail her like and let her know by tomorrow, like whenever she replies.
Then can someone repeat the answers of this one? The current one, the C part, all of them.
Vedant.
But we don't know which are correct, right? So how can we?
The first three are
The
same.
first three are same for us, only the fourth one is different.
The first one is 5 ohm, the second one is 1.2 amperes, and the third one is 0.72 amperes.
Yeah, now question 9.
And the third one, what do we take the voltage as? The resistance is 2 ohm. What do we take the voltage as?
I took 1.44 volts.
Why?
Because I found the voltage of the resistor connected to the B terminal, and then I subtracted the voltage from that voltage from the terminal voltage.
That is one method, and the second is like. Should we move on to the 8th question?
Yeah.
So everyone has done like one. Who wants to do the question 8? Like volunteer. Akash, you do it.
I haven't attempted it. I can do question 9.
Okay. Hitanshi, you want to do like alphabetical?
I haven't attempted.
Mishti.
Haven't attempted.
I attempted it. Should
Yeah,
I
you can do
try?
it.
The first answer I got 145 hours.
Yeah. On average.
Wait, won't 145 hours be for the entire month of February?
How
On an
many
average,
hours
it will
per
be
day? So like I got 145 total and then 145 upon 28. Wait, I didn't do that.
29, right? It's a leap year. 29 is a leap
29
year.
leap year.
29.
Oh, sure.
Like first you did that
5 hours.
60 is equal to 8.7. What was the first step?
What? I did first you convert kilowatt hour to water, then you do power is equal to E upon T, then you get T as 145 hours, then 145 upon 29 is 5 hours, so 5 hours per day.
Like I got 0.145 like instead of 145 because I took that watt hour instead of kilowatt hour. Come on.
Yeah, so that'll be 8700 upon 60.
Like the commercial unit should be kilowatt hour or watt hour.
Kilowatt.
Total unit is kilowatt hour.
Okay.
Then the next answer, I wrote manganese and constatin are used to make standard resistances because their resistance remains almost constant with any increase or decrease in temperature. Is that correct?
Yeah, and second is that the specific resistance is more than copper and aluminum. I don't know.
Then for the C part, what change? What's up? Name the process taking place along AB. I wrote melting, because solid to liquid.
You forgot the B one.
Yeah, and then the B part of what? Oh, show a ray diagram. I mean, how do I show?
No, the application is camera lens. Or what? No.
Yeah.
Slide projectors.
Could you show the diagram on the camera?
I didn't draw the diagram. I just did it as an extra question.
Is it like this?
I think so.
The C part, can you repeat?
And then for C part, the first answer I got melting, and the second for solid, I got the heat capacity as 0.1 calorie per gram per Celsius. And for the liquid, I got 0.28 calorie per gram per Celsius.
Calorie?
So we convert calorie to joule and then solve.
I found it easier to take it as calorie. And in the textbook also they have mentioned like you can use calorie. So instead of converting, I just did that.
What did you say the answer was? 0.1 and?
0.28.
Question 9. Who's done that? Anyone?
I can do question 9.
Okay.
Question 9a. Describe the observation with the tubes A, B and C when the vibrating tuning fork is placed over the mouth of these tubes. So in A and C, no resonance will take place and hence no loud sound will be heard. Whereas in B, resonance will take place. Then give a reason for the same. The reason is that in A and C, air columns are 8 centimeter, 6 centimeter. A, B, and C air columns are 8, 6, and 4 centimeter respectively, and the air column in D is 2 centimeter. So as resonance is occurring in D, it will also occur in B as it has the same natural frequency of vibration because its air column is 3 times of that in D, and thus resonance occur. Whereas A and C will have a different air column and hence is with a different natural frequency and hence resonance does not occur in them. And the principle is principle of resonance.
For the
I have
second
a
one,
doubt. Yeah, go ahead.
for the second one, the revision, can we just say resonance takes place, or is it just for 1 mark?
Yeah, but you just need to say the main point that it's 3 times. Its air column is 3 times that of D.
For A and C, do we also mention that force vibrations will take place, but like the sound won't come obviously because resonance doesn't occur?
I don't think so because you are saying your it depends on your observation. What did you write for observation?
Observation, I wrote soft sound for A, soft sound for C, and then loud sound due to resonance for B.
Yeah, but you can write that, but I think mainly you have to write about resonance only. That can be an additional point, I think.
Yeah.
The principle
I have
of
a
resonance.
question. Sorry.
No, go ahead.
No, I was just asking if they say state the principle, do we have to like write the definition?
No, just state. No?
Because I think I remember last year or something. I don't know.
I guess we have to
I
write
remember.
I get this.
illustrate, right?
You have to
Illustrate.
write
You
it
write the
because
statement.
when they ask name, you only have to name it. When they ask state, you have to give the state.
So what will be the statement?
Definition of
Just
resonance.
definition. Yeah.
But is there anything like principle of resonance?
No, I
but
think
then
it's
what
just the
will- what
definition of
will-
resonance.
I think instead of writing principle of resonance, can we write resonance on its own, or do we need to mention principle of?
I didn't really realize what principle is there in this. Like,
I guess resonance will be okay.
Resonance can only be the answer, but like, is resonance a principle?
No.
yeah, that
No, but they mentioned it. in the
Resonance is a
question.
phenomenon.
principle of force vibration.
Principle of resonant vibrations.
Yeah, I think we can write that. Principle of resonance. But then what will be the statement? Just a definition of resonance, no?
I think we can just write resonance. We don't have to clarify that it's a
Yeah.
principle.
Exactly.
Definition of resonance will be the statement, no?
Yeah.
Okay, then B, state the relation between, derive a relation between MA and VR of an efficiency of a machine. So it will be MA is equal to efficiency into VR. Then should I explain also? Does anybody want the explanation? No. Then what should be the angle between the force and the displacement to get the minimum work? It should be 90 degree because cos 90 degree is equal to 0 and work is equal to F into S into cos theta. I had a doubt over here, why can't theta be 180 degree? Because then the work will be in minus now, which will be lesser than 0.
But that's minimum, right? That's the most minimum.
Or
That's the most minimum work possible now.
yeah. Then
So
C
should we
one.
write 180 or 90?
I guess 90 because you don't have to do any work there. Like, because in one, like 180 you're opposing a motion. So
Yeah, we have to do the work in the opposite direction over there. But here, there no work is being done in 90
But
degree.
anyway, work is negative, which is less than 0, like you said. So then,
Yeah, but here we aren't doing any work. There we are doing work in an opposite direction.
so 90 pakka.
Yeah, because then when a fielder is taking a catch, he does a work now on the ball. So that is minus. That is 180 degree ka example. Then
But even the Earth moves around the sun, it does work, right? But the angle
Yeah.
is 90. When the
90.
coolie rocking does some work, but the angle is 90, so the work is 0. So work is done there, but the angle is 90, so that's why it's 0.
0. Then one isotope of uranium has a mass number 235 and atomic number 92. What is the number of electron in the neutral atom of this isotope? 92. Then what is the number of proton and neutron in its nucleus? 235. Then do all isotopes have the same number of neutrons?
Individual number, right?
Yeah.
What?
Yeah, even I.
Like the number of protons and
protons and
electrons
neutrons
respectively. Protons and neutrons.
Because it says number of protons and number of neutrons.
Okay. Are you sure? Because sometimes, sometimes they ask what is the number of protons, and in the B part they ask what is the number of proton and neutron.
But
No.
that is like
No, but see, if they were asking together, they would have said number of protons and neutrons, but
Yeah.
they've said number of protons and number of neutrons. So I think it means individual.
Okay. So number of neutron will be 235 minus 92, no?
Yeah, 143 I got.
Yeah.
Okay. So, do all isotopes have the same number of neutrons? Give reason. No, they do, they are atoms of the same element with the same atomic number but different mass number. So, as the mass number increases, the number of neutrons also increases, and thus isotopes of the same element have different neutrons.
Is
Any
that
other
the,
reason anybody has given?
like that is one the reason, like,
No,
because
I wrote the same.
like if the mass number increases, the like there are exceptions where the number of neutrons decrease. Like example 18, 20, 22 in the case of
No, that I've just given an example. But I've written mainly the answer is the atom of the same element with same atomic number have different mass number. That is the main reason.
I wrote same atomic number implies that they have the same number of protons, and if there's a change in the mass number, it can only be due to the number of neutrons.
Yeah, that's what I've written. Like, at least that's what I've tried to write. Then, what is the number of proton? 92. See, here they have asked the number of protons individually. Why will they ask you again?
I think they mean atomic number by that.
Yeah, it's 235 only.
No, I meant like they want us to write what is the number of protons. The number of protons is the atomic number.
But in the B part again they have asked what is the number of proton and number of neutrons. I think it is 235 only.
No, I mean like the answer for 4 is atomic number and the answer for 2 is 92 and 143. Because the number of protons is the atomic number of the element.
Oh, you're saying the what is the number of proton? You're saying the answer is atomic number.
Yeah.
No, I don't think so. You have to write a number.
No, atomic number in words. The answer.
Yeah, I know, I understood. But I don't think so that's correct.
I think, like, I mean, what is the number of protons? I think they're just asking us a general question. And in the textbook definition, it's written atomic number is equal to the number of protons in one atom of an element.
No, I don't think so. I think they are asking a number.
And even for the first one, it can be atomic number, right? Because atomic number is the number of protons, which is number of neutrons.
But in that one, they have clarified what is the number of protons and number of neutrons in its nucleus. And in this one, they're just asking what is the number of protons.
No.
You can define what are protons in your, I guess, in the fourth part.
You can just write number of protons is equal to atomic number, which is equal to 92 if you want to be safe.
But they are not asking number of protons for this nucleus. They're just asking. That's what I inferred as.
I think so. We have to write 92 only. And B part, I think so. Answer is 235. I'm pretty much sure because I've solved some board papers also there. Also, they have asked what is the number of proton and neutrons. So the answer was given 235.
You are saying the answer yourself. Like they have asked what is the number of protons and neutrons.
Yeah.
But here is written number of protons and number of neutrons separately.
Yeah, and only.
Why can't we just write both? It takes barely 30 seconds to write one more sentence just to be on the safer side.
I don't think Lata Miss will accept options for prelims.
Yeah, that she will do.
They're not options. I have always done this in my paper. You write both the sentences so that it's technically not wrong. So the number of protons are 92 and the number of neutrons are whatever 235 minus 92. And the number of protons and neutrons are 235. So you're not giving options technically.
Yeah, instead of the debate now we can just write that. Yeah.
So, but then for the fourth one, should we write the number or should we write atomic number?
Right. So I'm sure number that I think so.
Number is equal to the atomic.
Yeah, that's what I said.
Number which is 92. So you're writing both the answers in a different way.
Great. Last question, anyone?
Also, the answer of the first one is 92, right? In a neutral atom, number of electrons in a neutral atom.
Yeah.
Last question, any volunteer? Like one can do A part, one can do B part and C part.
I have done as an extra, but I haven't drawn the diagram.
I can do the C part.
So Mishti, you can do the A or B, anyone.
Okay, fine. So the A part, an object is placed in front of a converging lens at a distance greater than twice the focal length of the lens. Draw a ray diagram to show the formation of image and state its application. So the ray diagram is the beyond 2f1 wala. The image is between f2 and 2f2. It is inverted, real and diminished. And the application is a camera lens. The B, the focal length of a convex lens is 25 centimeter. At what distance from the optical center of the lens an object should be placed to obtain a virtual image of twice the size? I got minus 12.5 centimeter.
Same.
Yeah, even I got that.
First you use the magnification का formula ना, like or
Yeah,
Yeah.
first you use magnification का formula, then you get V is equal to 2E.
yeah.
Hiranshi, if you were saying something earlier, you were frozen. She's frozen, oh god.
Yeah, now also she's frozen.
Yeah, 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 yeah. To you, yeah.
The C part.
So in that question we get V as 2U. The focal length will be negative, right? Minus 25. And even the distance of the object will be taken as negative.
No, and there's some like the focus, like I took like 1 upon 25 is equal to 1 by 2v minus 1 by u, like because you're not substituting the exact values, so like we don't have to substitute the signs, I guess. So I took like,
Yeah, we don't have to substitute the sign. The sign will come on its own when you solve.
yeah, like I guess like it is only for the like we when we substitute the values, example like 25, they have to put the sign, but here it's convex, so it's positive. Isha in the C part.
I was talking about the lens formula only. There we have to substitute with the signs, right? 1 upon F is equal to 1 upon V minus 1 upon U there.
There like
But
what's
F
up?
is positive for a convex lens always.
Yeah, so what is the final answer for you?
Minus 12.5. Like for 2u and minus 1, like u, you don't write minus u because like the value isn't there, right? I'm talking about that only.
Should I go to C?
Yeah.
This is the diagram. Is it visible?
You have to draw more arrows, no?
3 from
Yeah, so like the beta rays, they go towards the positive plate and they are the most deviated. The alpha rays, they go to the negative plate and they are like second, and they are like less deviated than the beta, like they are thoda aage than the beta rays. And then the gamma rays, they just go straight. I didn't draw more arrows because like I didn't have that much space, but in the final paper. Then for the second answer, why is the source S kept in a thick lead ball container with a narrow opening? Source S emits radioactive radiations, namely gamma, alpha, and beta rays. The alpha rays have very less penetrating power and are easily stopped by a narrow or thin metallic sheet. The beta radiations have high penetrating power and need a thick metallic sheet to be stopped, whereas the gamma radiations have highest penetrating power and they are stopped only by a 30 centimeter thick sheet of lead. Hence, the source S is kept in a thick wall lead container so as to prevent the radioactive radiations from penetrating through the environment and affecting the persons working with the radioactive material as well as outside.
Can we just write the last part?
Yeah.
Or in the textbook, it's given
You have to
longer.
write.
You don't have to specify all of them.
Yeah, I guess it's if we write the last part only.
This is only one,
But like, I mean, you only need a thick sheet for the gamma.
Yeah.
You don't need a thick sheet for alpha or beta. So
No,
why
but-
would you use a thick wall sheet of lead?
But lead is preventing them also, na? So it is.
But you need to clarify
All the
for
things.
which one you need a lead now, because alpha sheet can be, it doesn't go even in air utna
Yeah, we
aage.
need one line, but you wrote like 4 to 5 lines.
Yeah. So like if we only read the gamma and if we only read the last part, it's okay.
Yeah.
Then the radiation which is unaffected, the gamma radiation, and radiation which is reflected the most, the beta radiation.